Well, good morning, folks. This is Steve Rayburn here at US Duct, and welcome to our May Advanced 3D Design class on Duct Quote. Uh, Duct Quote continues to evolve and gain new features and improvements. And as you've probably heard us say before, this webinar series is how we are keeping you abreast of those changes and helping you get the most out of this amazing tool. Now, in this session today, we're going to be looking at the how and why planning must be an integral part of your system design. And questions like, well, how does a line drawing actually translate into duct and into fittings must be considered and reconciled with the conceptual system that you or your client are expecting to create. Now, actual parts obviously have actual sizes, lengths, reaches, and it all has to fit into the space provided. So we're going to go through several examples today. I'm going to go ahead and hop into our training area. And the first example that we're going to be talking about today has to do with, you have to think about, are we going to be using hard connections to our machines, our pickup points, or are we allowed flex connections? Now, when somebody tells you that they want hard duct connections to their pickup points, you need to ask them why and how that's going to work. Now, it may be that their connection points require a flange to be connected to, and that's a good reason. You might expect then that you're going to have to put a flange adapter on the end, or you might be using all flange duct. Okay. And again, typically you can in fact use those hard connections to those pickup points as long as the proper amount of space is allowed to get all the fittings into place. Now what we've got here is an example. Now I have not drawn this to height, but it is very easily demonstrated. What we've got here is a trunk going back into a larger trunk. And this is our first drop. Each of these is where they wanted to locate a hard connection. So I'm going to show you that here we've got, I believe it's a 14, yep, inch trunk or sub trunk, if you will. And here we've got an 8-inch drop. Well, if I take another 8-inch drop and try to fit it in on top of where they have things drawn and let that connect, we're going to be told that this does not fit. Okay, so if I now look at how much extra room we need, well, basically the difference between 15 and 21. So there's 6 inches that have to be dealt with. Well, for a hard connect, an 8-inch connection moved 6 inches off center, you're going to have some difficulties. So one of two things has to happen. Either they've got to move this, or they've got to have you create a manifold. In this case, it would be a 4-drop manifold. Or if we were to go to Flexos, that solves a lot of the problems. Uh, Literally, we could tell DuckQuote to, okay, fix that downstream. And with flex hose, you could certainly move that over the 6 inches that would be needed. Now, if this were a flange connection here, you could do something as simple as having a flange adapter to a hose connection style, and then the flex hose could connect there. Okay, but you've got to talk this through with your client so that they understand and you understand the limitations of and the advantages of using standard versus, say, a custom part. All right, so that's kind of example one. Is we can only fit these branches just so close together, and that is based on the sizes of these entrances and exits. Okay, now the other thing that impacted this is you'll notice that they've asked for a non-tapered subtrunk. Well, if in fact we were to have the system size this, then that piece way out there, that end, would really technically be an 8-inch, and we could actually calculate what we've got, and we would end up with something that looks a bit more like this. Now we would still have to move things out just a touch, but again, the size of the openings on your branches and on your elbows are what really determine the actual length and sizes of them. And you've got to pay attention to that or work out some way to mitigate the problem. Okay, so that's example one. All right, so taking a look at example two. Example two, we're going to be talking about the length of those branches. And you've got tight tolerances where trunks have to run if that's the issue, and you're combining two subsections from opposite directions. Well, you might not be able to use a Y branch because of the actual position of where those opposing subtrunks are coming from. And you can see here that where they had given the actual size of their combined subtrunk, one of the issues was that they wanted an 11.5-inch diameter piece of duct. Well, we don't make that. We make whole integer diameters, if you will. So we offered them a 12-inch, which they accepted, but they still needed to combine two sections that were both 8 inches. And as you can see here, that means that once again, we've got, looks like about 2 inches of difference. Now, if this has got to be hard connected, 2 inches might not be a big deal unless you do have to hard connect. And then it can become a huge deal. So how could you do this? Well, one way to get around this might be, instead of using a pants Y, we might be able to do this as follows. If we take this out, and what I'm going to suggest is an elbow followed with a branch, okay? So if we were to come down and extend this, and I'm just arbitrarily choosing this side to do this, and we're now going to draw up and connect. Now, because I'm bringing two dissimilar sizes together, duck quote assumes I'm trying to create a branch. Well, I am, okay? But if we now draw from here at 45 degrees, and this will again be our 8-inch, and bring it over and connect it, you can see that we still have to make this longer. So if we do that downstream, okay, we can kind of move this back, and I'm going to redraw this so that I can actually reach the correct. We're going to draw that again, 8-inch at a 45-degree angle. I'm going to come down till I am even with that. And as you can see now, we didn't have to move this end. Let's say that's one of the criticals. And we didn't have to move these two opposing sizes, but we did have to change how we handled the connection there. And this all now works with standard size. And if we needed to change this back, we could bring this back just to the elbow, it looks like. And you can see that we're now finishing at those reducers, and that would work, right? So that's what we mean by a combination of an elbow and a branch. Sometimes this is a much better way. It sometimes is also better for your pressure loss. So let's close out there. So let's take a look at example number 3. Now, example number 3 I've titled, "There's no such thing as a branching elbow." And by that, we have often had people draw a branch like this so close to something here that it in fact causes, well, what amounts to a branching elbow. And I actually, just before we started this morning, found what I think is a better example here. So here's what I'm going to do. I'm going to bring that on, and this would be an example of how you might see the line drawing. And you can see that right in the middle of the elbow, somebody has drawn, okay, they expect the branch to happen there, right? Well, that really cannot happen. We can't, with a standard piece, do that. Now, if you had to, you could build some kind of special thing. But again, there's a way around this. So if you will allow me, I'm going to turn that off, the drawing. And what I'm going to do is I'm going to offer the following. We're going to come up and we're going to draw, and we'll use, let's say, 10-inch duct. And we're going to say that that's going there, and pretend that this was that elbow that they were trying to draw their branch from somewhere in there with, say, I don't know, a 4-inch, right? Well, as you can see, that just isn't going to work, right? So let's take a look at how we might fix this. We have to turn the corner, but if we can back up slightly, and even back up slightly here, and then we bring these two together, let's say at a 45-degree angle. And we're going to say that both of these now have 45-degree elbows. Okay. We can now take that 4-inch piece and you can see here, now that works. You've still got the turn and you've got your 4-inch piece, which is essentially in the same position that it was before. So you can see that that would work both for the positioning of their piece of equipment over here, as well as making the right-hand turn without changing where these two trunks really are. The only difference is you're cutting the corner slightly right there, okay? Now, stacking fittings on top of one another, it works as long as you allow for the appropriate space, just like we've mentioned. You cannot merge things into each other without creating some kind of a custom part. And it's very important to remember that some things that are available in galvanized are not available in stainless steel. This goes back to planning again. The same thing is true having to do with different gauges. Some things are available in certain gauges and not available in other gauges, okay? There actually is a machine that has limitations on what it can roll, what it can bend, what it can process. And that is part of how we determine what is available in gauges and in sizes. So here's my kind of final mention about planning. We've often gotten, well, not all that often, we've gotten a few requests for the ability to merge one layout into another. In other words, they've drawn two separate systems that go into the same space, essentially. And they want to bring those two layouts together to combine them. This is fraught with massive complexities as far as the programming of that in a program like DuckQuote. The biggest and probably the easiest to understand is the scaling involved. In other words, in one drawing where the literal distance here is representing, pardon, 6¼ feet or 6 feet and 1/4 inch, okay, may not be exactly scaled the same in the second layout. And that's the problem. To be able to merge them, not only must the scaling be exactly the same, and I mean identical, but there has to be some sort of a reference point that is common to both layouts, and the receiving layout has to be large enough that it accepts everything in the two being combined. Well, that really is kind of rare. It's almost never identically scaled, the two. And because of that, we just do not have the merging of two layouts in DuckQuote. Instead, back to planning, if you believe that you're going to be asked to show a combined or full layout, plan to draw it that way. Draw the entire set of layouts all together as a single entity. Then create copies and delete out the parts that don't need to be in that particular copy. That way you've got the combined as well as the individuals, and you can print the individuals as their own orders if you need to, or their own layouts. So that kind of walks you through, why planning is so important. It will save you an immense amount of time if you will sit down and usually it takes less than 5 to 10 minutes to walk through, look at what you have, understand what you're creating, and then plan it out, okay? Very often in that planning, initial thoughts that you had about how something might be routed, you find better ways. And so it just works to better the entire outcome. Well, that's it for us today. I do want to invite you to tune in next month. We have a advanced class coming up on the 22nd of June, and we're going to have a special speaker, a young lady who's one of our systems engineers who is an expert at reading drawings. And so one of the things that we have noticed folks have a great deal of challenge with is reading drawings, because not always conventions are followed, or how you need to understand what that drawing's trying to tell you about the three-dimensional world into which this is going to fit. So tune in, look for that email with the invite, and guys, have a great rest of the week and weekend. Happy Memorial Day to everybody.